Hello.
Hey, good morning. How are you?
Good. How are you?
I'm doing well.
Did you
All
have a good
right.
weekend?
I did. I did. How about you?
Very chill. I'm starting to pack. So trying to take it one thing at a time. I got my first box done yesterday and I was like, okay,
Beautiful.
here we go.
That's exciting.
Yeah, I'm excited.
Very cool. Very, very cool. Okay, cool. Well, let's hop right into it. So we're going to build on our earthwork and kind of utility, a civil, basically foundation that we kind of built last week and the week before. And so we're going to be talking about foundations, which is Division 3 for the CSI codes. We're going to talk about footings, slabs, rebar, anchor bolts, kind of forms, and then testing, budget, all that kind of good stuff. So, footing, slabs, and rebar cover. So the cover, anytime you talk about something being covered, that's the distance between, as a definition, it's gonna, so if you have 3 inches of cover, that means you've got 3 inches of whatever that is. In most cases, that's going to be like concrete or before it's, from the outside of it to whatever's on the inside. So for instance, think about it like a rebar cage that's maybe inside, and we'll go over this in a minute, but a rebar cage that's kind of set down in the hole. If the edge of that rebar is 3 inches to the edge of the concrete, then that's called 3 inches of cover, basically.
Okay.
So, uh, formwork, anchor bolts, and then we're going to talk about some things that we need to make sure that we do on like pour day, and that the superintendent is doing, and then rework, of course, is expensive. So we'll talk about the risk on that, and then budgets, and then we'll do a review at the very end. So I did put in here, these are the same links that I sent over yesterday, but they're just some general 10,000 foot view, a lot of definitions, a lot of stuff to talk about regarding a slump, plan reading. Plan reading is probably going to be pretty important because you'll be looking at a lot of plans.
Mhm.
So you'll need to be familiar with what a footing looks like or what a foundation wall looks like, and also reading the schedules. So we'll look at some individual examples there. But that guy, the same guy that I used for the plan reading, he's pretty comprehensive. He does all kinds of stuff, and he explains it in very easy to understand videos. So he does a pretty good job of that. And then just some more videos that we had come up with. These are a lot of OSHA stuff, so you'll cover that in your, so like for instance, your concrete and masonry. That's going to talk about like when you have rebar stub ups, they have what's called a rebar cap that has to be put on them. So a rebar cap, and we won't go too far into this because you'll learn a lot of that when you're doing, when you go through your OSHA. But essentially, these are rebar caps.
Okay.
So some of them, I need to check the guidelines because occasionally these are spec'd out. Most of the time they're not. But essentially, that's exactly what they're for. So
Oh, okay.
you put them on top of your rebar so that when they start pouring, because this is obviously going to have like a wall or something that's going to go onto it. So we would see this very commonly in like if they're pouring the pier caps separate from the foundation wall, you'll have stub ups, or the footing. More importantly, if the footing's being poured separate from the foundation wall, then you'll have the rebar that'll actually stub up, and it needs to be covered with a rebar cap. And that is a OSHA requirement. So if any subcontractor gives you beef on it and says that they don't do that, then obviously they have to follow OSHA compliance and they should do
Mhm.
it. So,
Okay.
um, but very important, because as you're pouring concrete, if somebody were to trip and fall,
Yeah.
that's where they can impale themselves really
Mhm.
quickly. And that rebar is, I mean, it's steel, it's going right through you. So,
Yeah.
Silica is the dust that's actually is the dust that comes off of concrete. So you can actually get cancer from it. So that'll be you'll go over that as well. But that's why I'm, anytime you're sanding concrete or or grinding concrete or anything like that, it creates a silica dust, and it is toxic. To not like it's like asbestos, where it's not going to kill you like right then, but over a period of 10 years or something, if you continually breathe it, then that's where it gets you. So and then just some other we'll go over slump test and exactly what that means. Of course, taking concrete cylinders, that's important. That's how you actually test the concrete. And then any ACI inspection certifications. That's just a quick little read on not anything that you'll be responsible for on a daily basis. It's just knowing what people are talking about when they're talking about it. So, all right. So footings and slabs. So foundation. So these are going to be just some definitions and some terms. So foundation plan. That's your when you're looking at a drawing from, and let's pull up an example. So when you're looking at a set of drawings, come on, man. Yeah, there we go. Let's do that. Okay, so let's just take, for instance, on our West Bridgewater project. Actually, you know what? Let's look at Dalton. Permit set. Let's see if we actually had some decent foundation drawings here.
Oh, I have this set right here in front of me. Let me pull it up too.
All right, so that's the demo. First proposed floor plan. We'll get into that. Okay, here we go. All right, so this would be your foundation plan. So and they call this plan view. So whenever anybody says, you're looking at it in plan view, or you want to reference that you're looking at it in plan view, that's always looking at it from the top.
Okay.
In contrast, if somebody says an elevation, this would be an elevation view. So it's basically like you're standing in front of it looking at it.
Okay.
Is the differences there. So looking at this plan view so this is a plan view of your foundation. And you can see that it's got several notes called out here. They don't really call out the actual footings like they do on some jobs. So you would actually have like if this and these aren't actual quote unquote footings per se. These are now this is, so this would be a footing right here. But we need to look at the section view to see so let's do that. Let's just look at that real quick. 402. Yeah, so actually here is your footing down here. So you can see that it's called out as 10 inches and they've got it at -4 foot because that's going to be front. So, this is the bottom of frost wall is what this is. So this is only something that you're only going to see this nomenclature in some place that it's cold.
Okay.
You're never going to see this in Texas. Typically, it's never going to say frost wall.
Okay.
But essentially what you would do is the contractor could either pour this all at once, or he could pour it, which it would be called monolithically. So if he poured every bit of this, so all of the wall, the foundation wall, and the footing all at the same time, that would be a monolithic pour. If he chose to do it separate, that's fine. You would just have a cold joint. So any place that you hear the word cold joint, that means that's two materials that are coming together. In this case, it's concrete and concrete, but they're not like the only thing that's joining them together would be if there were any, which I don't see it here, but there should be some rebar that would be stuck up. Now, There will be instructions on some drawings that tell you whether or not you can pour it monolithically, depending on the engineering. Sometimes they don't necessarily want it poured together. Other times they do want it poured together because their calculations have taken into account that. So that would be a note on the drawings. If you don't see a note of anything, and then it's means and methods. It's however the contractor wants to do it.
Okay.
Is the way that it'll be done. Let me see here. So this would be a good example of. So this is a typical. This is actually a typical frost wall details. So this would be like, say, 4 on S 1.02, A on 101. Let me see, what page are we on here? We're on 102. And we're looking at detail 1 on page 102, S102. So I want to find detail 1 on S102. So I'm looking for it to say S-102 right there. There's 2 on S102. There's 4. There's 1. All right. I'm going to say that we've got a typo. And here's why I'm going to say that. So let's look at A402 real quick. And I could be wrong. I'm probably wrong in this case. There's 1 and 2, which could definitely be the detail that they're referring to. But the problem is, like, they don't give you any details for the foundation. So let's go back here. Let's look at 2 on S102. So 2 on S102 would be right here. So that is a typical steel column on exterior wall detail. That's what they're trying to tell you there. So if we go back here, you can see that this cut is through. So this would be a section view. So it always tells you, the arrow always tells you how you're looking at it. So
Okay.
you would be looking at it from, if you were standing back here looking this direction. This is what, and say, so imagine you're down in the hole, you're down in the trench, and you're looking at it from that direction. This is what you would see.
Okay.
So you would see the footing, and it shows to be an existing footing, assumed. Of course, they're assuming that this is actually there. So if we go back, that is actually going to be the exterior wall. This was the existing exterior wall. So if we go down to see, so this is where we could ask RFIs, because I'm going to assume there's no call out here, but this looks like it would be that it's not on a column line. I don't see any columns here. So this is probably our standard detail. So we can see the exterior of the building here. It shows the faux stone on the outside. So this is going to be an exterior wall. So this section view that they don't actually should have a little number and should have an arrow, I don't see it. So very typical error on the architectural, or excuse me, on the structural drawings.
Okay.
So we can do an RFI on that. But and verify that is accurate, just to have it in writing, because we don't ever like to assume anything. But anyway, that's where that would be. So that should say 1 and with a line and say S-102. And that would tell you, okay, I need to look at page S102, detail 1. And that gives me the same section view. Okay. Let's see here. Now, let's see. So, okay, so footing schedule, pier column schedule, rebar reinforcing schedule. We'll hop into all that, and I'll show you details on what that looks like. On this set of drawings for Dalton, we don't have any schedules that I can tell. Everything is basically called out so that we have a 4-inch, it calls out number 4, rebar horizontal at 4-foot centers. So that means that that rebar is going to be number 4, which if you Google it, number 4 is going to be, should be 1/2-inch rebar. So you can kind of, one way that I think about it is like if it's number 5, you always put it under 1/8. So they're done in eighths. So if it's called to be number 4, that's going to be 4/8. So that would be as far as if you're looking for a diameter of the rebar.
Mm-hmm.
So that would be, which would be 1/2-inch, right? 4/8. Mm-hmm. So if it's number 4, that equals 4/8. So then number 5 would equal 5/8. Number 6 would equal 6/8 or 3/4. And let me make sure I am thinking about that right, because
yes, you are.
Okay, good.
Yeah.
Yeah. Yeah. And you can always Google it. You can always, these are the standards.
Mm-hmm.
So they always give you a weight. So rebar is sold by the weight. Not that you'll need to know that. But when it's sold in big quantities, it's sold by the weight. So however much tonnage you have. But in any event, that kind of gives you the nominal. So the reason that that's important is that when you look at rebar shop drawings, right, you need to know what a number 5 is. You need to, because sometimes it'll be called out as number 5. Sometimes it'll be called out as 5/8. Just kind of depends. But you would actually have in the schedules that we're going to look at, it's basically a schedule. Anytime you see the word schedule, it means table. And it's just a legend, right? It's a table that tells you what things are. And you would see in there that it would call out the actual rebar size that was supposed to be used in that particular footing. Okay. Since this is a smaller build and we're not really doing that much of the foundation, because all of this is assumed to be existing. So the only stuff we're adding is really from here back. So from basically this line, so from right in there to right in here is what we're adding. That's the only foundation we're adding. So they didn't go to the trouble of making any kind of schedule.
Okay. So when I was looking through the plans, there are schedules in these plans, but for architectural stuff, not for the foundation, but
correct. So so you'll have an equipment schedule. You'll probably have a finish schedule somewhere. Yeah, floor finish schedule. You should have a room finish schedule. All of those schedules, and typically they're all done the same. So it would call out whatever the floor finish is, whatever they're using. So F1, F2, F3. So that would be, floor finish 1, floor finish 2, floor finish 3, and then actually what they are. But you should be able to look at any set of plans, go to the architecturals, look for a room finish schedule should tell you the room number, the description of the room. It should tell you what's on, how it's finished on one wall, how it's finished on the ceiling, how it's, that's why they call it a room finish schedule. So.
Okay. And now this isn't technically in regards of foundation or concrete, but on the schedule for Lipton Market, there was a section on one of the schedules. It kept saying verify on a few line items, and so not the graphics, but is that where you would then have, I think it was that one, is that when you would have a submittal?
Yes.
Okay.
So all of these verifies on here are to be used. So it's basically you're going to see the word verify a ton on any set of drawings. Basically, if the architects and engineers don't know, then they put, it's on the contractor to verify.
Okay.
So this is where we would get, which we have for this one, because I actually have sent all the equipment cut sheets. I put together a package, and we actually sent that to, because we're not providing the equipment here. So I sent that to the electrician so that he would know what he's supposed to be running. So then he would look at it and say, okay, the freezing condenser, I've got a cut sheet for that. And so he would make notation of what the volts are, what the amperage are, and what the phase is. Now that's important because when they go to pull wire, if they pull the wrong size wire, they're going to have to pull it again for whatever. And there may not be room in the conduit. There may not be, whatever. That's why it's hyper important, super, super important. When we have a kitchen, when we have any equipment that the owner's providing, that we get those cut sheets and we make sure we get them to the electrician and have him verify. As the first verification, we have him verify, because he's the one that's actually doing the work, that the electrical drawings actually match the equipment that he's going to be putting in. All right. The other thing we can do is use AI. We upload the cut sheets, we upload the equipment schedule, and we ask AI to do an analysis and provide us with a new equipment schedule.
Okay.
Yep. And again, it's going to be hit or miss. Sometimes they're going to misspell things. Sometimes it's not going to be right. But for the most part, it'll at least get you like 60, 70% of the way there.
Okay. I had gone through and highlighted all the verify ones. And I mean, there were a lot. And then I looked on the submittal tab in Procore, and there are some that are missing that weren't, which I can just send in an email, or we can talk about it another time. But anyways, I just wanted to make sure, because when we had met about Lipton, you had said to look at the plans and see kind of what I felt needed to be a submittal. And so I just made notes of some things, but I just wanted to make sure that with a schedule, that is one of the places you would find items that would go into a submittal.
Yes, that's correct. Yep,
Okay.
You're absolutely right. And yeah, some of these we're not going to have, we may not have, well, obviously anything that doesn't require any kind of power, we're not going to have a cut sheet for. And anything that doesn't have, so basically if it doesn't, so any of these items we're not going to have, but we should have at least some of these, like the under counter sink, the faucets, the soap, because those are the ones that are being provided by the owner. The ones you're not going to see on the schedule pertaining to plumbing are going to be like your restroom, your faucet, your sink in the restroom, because they're not doing that. So yeah, just something to keep in mind. But yes, it's very hit or miss. Every project's different. It just kind of depends on, that's what makes our job so hard sometimes. So, okay, perfect. So we'll talk more about schedules. We'll get into those. I have some examples of that. Sections and cuts. We talked about sections, and how that would need to kind of be, or that needs to be looked at. You always, if you got a plan view, you should always have a section view that you're able to look at a cut on a wall, on a foundation, on whatever, because that provides almost all the detail that you need in order to build it. And then, of course, pay attention to your general notes, because that's where you're going to have your PSI for your concrete. So that's how they measure concrete breaks, is in pounds per square inch. That's when they break the cylinders. That's how they determine what the PSI is. So a lot of times for structural concrete, you're going to be anywhere between 3,000 to 4,000. And if it's not called out, then that's where your mixed design is even more valuable, because you'll get a mixed design, which we'll talk about in a second, that you'll submit to the design team, and the structural, you'll submit that to the structural engineer, and he will take a look at it and bless it and say, yep, that's the kind of mix we want for the concrete. And then that's what the concrete company will provide to the concrete contractor. So just to kind of keep that in mind, there's more and more on some of these, on these smaller jobs, they're not calling out the PSI on the concrete. So we always assume that it's 3,000 or 3,500, whatever it can be. There's not a whole lot of price difference in those, like maybe $5 a yard, something like that. So not a huge deal. We just need to make sure that we get it right. So, So you've got different types of footings, and different types of, so when you talk about a slab, that's not a foundation. Those are two different things, slab and foundation. So, uh, so this is a great example here. So everything from basically the bottom of the slab down is all your foundation, which is going to consist of your footing. It may consist of a foundation wall. It may consist of a pier. It may whatever. But just remember, anything below the slab is your foundation. Anything from the bottom of the slab up is just your slab, which is going to have that wire. It's either going to have wire mesh or rebar in that top, usually 4 to 6 inches.
Okay.
So this is all slab right here. Everything, like I said, everything below that. So all this is going to be foundation, foundation, foundation. And then if you have, they backfilled here, this is pretty common with what you would see in one of our car washes. We've got a foundation, we got a foundation wall. They're going to backfill with either stone or gravel. And that way they'll be able to get that to the exact elevation that they need. And then the slab is your top 4 to 6 inches. So just for definition purposes, that there is a difference between slab and foundation. Strip footing. So strip footings are, pull up a drawing, it'd be easier to see. So a strip footing is going to be like another word for your foundation wall, as we relate it to the car washes. So basically, it's going to be that wall that is in between. It's above the footing, but it's the smaller wall that is between the two footings. So like. Yeah, so this is a good example here. This is strap beams. We really don't call them strap beams. You'll hear that grade beam is the word that you'll hear. I don't I'm sure some people call them strap beams, but we always call them grade beams. They're referred to as grade beams in the field. And a grade beam is going to be anything that's basically connects your two footings, but it's the same height as the footing, if that makes sense. So that's why this would be a grade beam here. This would be a foundation wall. Again, they don't really call them strip footings. And the reason they don't is because we don't want to confuse these footings here for your columns. So you've got column footings, foundation walls, and basically grade beams are the three that we talk about all the time. Let me see if there's a better. This is a pretty good example here, other than the nomenclature. So this would be a typical. This would be a typical, this could be a car wash for all we know, because we've got. So this would be your footing for your columns. This would call this a pier cap, because it's typically only a 1 to 2 foot cap, but that basically goes on top of your foundation, and then the slab goes on top of it. This strap beam would be a grade beam, and except in our car washes, of course, it would be higher, right? So we would have this down about a foot, and then that would be our foundation wall. Yeah, that's pretty much the best example I can come up with. It'll just be a matter of you kind of seeing it in the field, and just being able to recognize the difference between a foundation wall and all of its foundation. Every bit of its part. Anything below that slab, like I said, is part of the foundation.
Okay.
So mat foundation we don't use on our projects. So a mat foundation is basically a huge slab. I think one of the videos probably covered it, but they use it in high rises and taller, bigger buildings. where instead of having a bunch of different footings, they just pour one big footing over the whole thing is what it's called. But like I said, we don't really get into those at all because our buildings aren't big enough that we do. Slab on grade is your slab. That slab on grade. SOG is another, that SOG is, is always slab on grade. They call it a slab. They call it, which is it's your finished floor. Whenever they talk about finished floor, that's your finished floor elevation would be your top of your slab or your slab on grade. Again, it's the top 4 to 6 inches. That's above your foundation. That's always, and it's always big and flat. So,
okay.
This is talking about rebar cover. So this is what we talked about a while ago. And these are general guidelines, right? So everything should be different in these, but you should always have at least a minimum of 3 inches of cover between your rebar and your this particular one is talking about chairs. So when you have a let's look at it's not a very good picture. That's what it is, but it's not. No, we don't use those. There we go. So the ones that you're going to see a lot are going to be these. Whoops, let's go back. It's going to be the plastic ones. You'll see a lot. So when they talk about 3 inches of cover, it's 3 inches from the ground to that rebar is where the chair is. This is a very common one right here. And then you will also see them in, and all of these do the same thing. So you may see these as well. They're not near as common, but you would also see what look like little bricks. There we go. This is a good one right here. You'll see that a lot.
Okay.
As a rebar support. Basically, it does the same thing. All it's doing is it's keeping that rebar off the ground. And the reason we want the rebar off the ground is because ground holds moisture, and then it would eventually, rust away it would eventually corrode the rebar over time if it were on the ground. So that's why it's very important that you have to have chairs, which are basically support your concrete. A lot of times they will not put those chairs in until the day of the pour.
Okay.
Because as people walk on them, as they, if they're using these plastic ones, if they walk on them, then sometimes the chair will break, so they always wait, and they'll have a couple of guys go through and put the chairs in ahead of their concrete pour. But you always want the chairs.
Okay. So if I were to go on a pour day and there are no chairs, we're not pouring until there are chairs.
Yes, correct.
Okay.
Yep. So walls, this is basically talking about your cover from on these particular items. So if you have walls or columns, beams, anything exposed to weather, which is fine, any kind of precast, just a rule of thumb is 3 inches for concrete, really. From the bottom of the chairs, usually it's 3 inches from the edge of a rebar cage. It's, 3 inches typically a good, now obviously you're not going to have 3 inches of cover like in a 4-inch slab. But what you'll see in the drawings is that rebar mat or that wire that they put as reinforcement in the slab is usually in the center. So on a 4-inch slab, you're going to have 2 inches of cover, basically. I'm not sure if they give us a good, let's look here. Let's see if they do. Actually, see, this one's not in the center. It looks like it's in the top third. So there is probably a detail somewhere. Okay, so this is a welded wire mat. So they're not using like traditional rebar. They're using a 6x6, uh, a inch and a quarter by inch and a quarter. So those are the squares. Excuse me, it's almost inch and a half. Those are the little squares. Well, I'm sorry, that's the gauge. My bad. I think that's the gauge. Let's look that up. I don't know. Let's double. Of course, I can't highlight it. So let's do this. What we're going to do is let's go. So it specifically says 6x6 W 1.4 1.4 WWM. All right, so that's what we're looking at. It's the welded wire, 10 gauge 6x6. To be perfectly honest, I'm not exactly sure. I should probably know what this 1.4 means, but I'm not exactly sure. That could be maybe the diameter of the actual wire itself, would probably be my guess, and it's probably in millimeters. But that's what you would. So that's what they're rolling out, and they're putting. Now the 10 gauge would be the wire size. So I don't know what the 1.4 by 1.4 is. That would be something I need to get educated on. The 6x6 is going to be your squares. So this is important because you'll want to make sure, like in your submittal drawings, that you have a submittal for the wire. And
Okay.
when we go to pour that concrete, you'll want to make sure that so this appears to be like in the very top, probably 1 inch of the concrete is my guess there.
Mm-hmm.
And then you also want to make sure that, so every slab has a vapor barrier, and it means exactly that. So this keeps moisture out of the slab. So it's a piece of plastic, right? And then of course they've got their 6-inch crushed stone. So we're getting a little off subject, but it's important that we talk about the vapor barrier, because so in your concrete submittals, you should have the wire and you should have the vapor barrier for that. So then your vapor barrier,
The 1.4, I ChatGPT'd it. It's the wire size in both directions.
Oh, okay. Well, that makes sense. Yeah, so that's got to be, so it's not in inches. So that's got to be in millimeters, I would think. I don't know what else it would be in, but so this is vapor barrier with rebar. Let's see if we can find a vapor barrier with welded wire. So we can try to see exactly see if we can find an exact example. That looks like welded wire. So this is what your slab should look like.
Okay.
So what they're doing, that's exactly what they're doing. Okay. So let's look at this. So the reason they have it elevated like this is because they're planning on them putting a 3-inch chair underneath that.
Okay.
So that's why it puts it in the top third of the slab. But they're laying their vapor barrier down. The other important thing about the vapor barrier is, and I don't see it necessarily here, but it should be, here we go. It should be, see how that's taped right there around your penetrations?
Mm-hmm.
When you have a concrete inspection, and your superintendent should be on top of this. So it's just something for you to kind of, when you see it, this is what you're looking at. But all the seams for the vapor barrier have to be taped, and any penetrations, like it's going to tape that vapor barrier to that penetration that's coming up.
Okay.
That's why when you're done pouring, so you can see them taping the seams right here. So when you're done pouring, sometimes you'll see like a stub up for a piece of pipe, and it'll have like tape around it. Well, that's the vapor barrier tape that it had used to tape it. So, all right.
And those, this, I don't, those don't get concrete over them,
What's
right?
that?
The um the stub ups. Am I
Well, no,
saying
no,
that?
no, they don't get, no, they just get concrete around them. If you get
Yes. Yeah.
concrete in them, you're in trouble.
Okay. Okay.
Um, so yeah, no, that's why they'll stub them up. And then once everything's poured and they come back to say set a toilet, they'll
Hmm.
cut that stub up off at the slab. And then
Gotcha.
they'll
Okay.
install either like a grate, or they'll install like maybe if it's a floor sink, actually that box is already there for them to
Hmm.
grade to, and to actually pour to. So
Okay. That's what I thought. I was like, that
sure.
they wouldn't pour concrete over that, but okay.
All right, perfect. So um, let's talk about. So this is where we tie it into like your subgrade. So remember talking in the civil, we talked about how critical it was for compaction test and to make sure that we were compacted correctly, make sure we had proctors so that we could do the test right and everything. So the building is only as good as what it sits on. Every structural failure begins with below grade, which is 1,000% true. So why is subgrade important? Subgrade quality important. So it's any undersized footings or anything. If you remember when we talked about it, the structural engineer gets that geotech report, and
Mhm.
he's using the advice from the geotech in order to design his foundation. So that's why the soil is super important. It determines the size of the footings. It determines the size of the rebar. He's using all that information to determine that. That's why another reason why when we get our submittals in, we have to make sure that it matches what he has called out on the structural drawings. All right. Um, we've talked about 95% compaction. We've talked about unsuitable soils. This is just kind of reiterating some of the subgrade stuff that we had talked about in the civil. So subgrade failures that the PM must prevent. So soft spots, where we talked about when you proof roll and you got a soft spot. We discussed that. Any rain saturation. So, for instance, if we have, let's in a real world scenario, say we've got it formed and we're getting ready to put rebar in. So once you do your forms, kind of how it's sequenced, once you do your forms, then you'll have before your vapor barrier and your rebar for your slab is the very last thing you're going to do.
Okay.
So typically they'll have that and put it down in like a day and then pour.
Mhm.
So we don't ever want to have more rebar or more vapor barrier installed than what we can really pour like in a very short period of time. Because
Okay.
if weather gets you, then before you've got the vapor barrier down, then you're going to have to deal with a soggy subgrade. You're going to have to deal with mud on your rebar. You're going to have to deal with, which the concrete doesn't adhere to the rebar properly if there's mud on it. So that's why in Texas, they will get in trouble sometimes because we don't use traditional forms when we earth form because we have clay soil here in East Texas, and some other places we've got even better soil. So we earth form everything. But if we put rebar in the hole and then it rains before we get a chance to pour it, we're going to have to pull that rebar out and we're going to have to redo the excavation. Okay, especially if you have dirt slough off or whatever else.
Mhm.
And if you don't do that, that's a reason for failure, right? So we
Okay.
always want to pay attention to weather when we're doing foundations.
Okay.
Um, Again, rain saturated subgrade that you pour over excavated, not backfilled with compacted structural fill, creates a void under the footing. So that's if you, and then of course not reading the geotech. That's we have the geotech for a reason. So,
Mhm.
um,
Is
oh,
that I know so for some of the car washes we did, we had the pour schedule, and not that the whole purpose of the pour schedule was because of weather. I mean, it had its own reasons, but is that where that would be beneficial? Is if, you're not preparing an entire site's worth of the concrete and doing the barrier, because you can focus on this one section, get that poured, and then if rain comes the next day and you didn't get to the next spot.
yep,
Okay.
1,000%. 1,000%. Same thing for like when we talked about the civil, we talked about the reclaim tanks and not wanting to leave that hole excavated like forever. And that's due to A, safety, but also B, the longer you leave it open, the more subject you are to having a rain event. And now you've got a hole full of mud that has started to cave in on you. And now you got to spend more time excavating it and drying it out. So,
okay.
But what it's talking about, so sometimes you will have a, let me see if I can find a decent representation here of what it's talking about. So sometimes you'll have a, don't really see it. Some of these pictures are not exactly the highest of quality here. Basically what I'm looking for is where you've poured a foundation, you've poured a footing, and the, I guess we could use this for lack of a better term. So let's say that, so in Texas, so you'll see this in the Northeast, but we'll over excavate and they'll actually do their forms for their foundations. You won't hardly see this in Texas at all, ever. Unless the structural engineer has purposely called it out and says that all foundations shall be formed. And not earth formed. That's typically a huge note. And if you're in Texas, because it's not the way things are normally done. But so if you pour this and then you pull your footings and we don't backfill immediately, at least some of it, and then this gets washed out underneath. That's what they're talking about in this slide when they say over excavation not backfilled with either structural fill or it creates voids under the footing. If this ends up washing out before we can get it backfilled, then we've got a problem. We've got to go in and reinforce that with what's called flowable fill. So just imagine it as like a, it's basically, think about it like concrete without the rock in it, without aggregate. It's just like or like a foam material, except it's not foam. It's a different material, but that's why they call it flowable fill. It will go into the cracks, into the crevices, and will support this. Basically, it acts like the dirt that had washed out from underneath it. So that is something that is 100% preventable. So that's not something that sneaks up on us. Like if we need to backfill, we need to get it done at least to the top of the footing. That way it protects the earth that's on the bottom of the footing. All right. Let's see the foundations, the foundation's job and the load path. So just so you'll know because you can spend a ton of time on this, and we're not looking to be structural engineers, but this just kind of gives you an idea of what they're thinking about. So it transfers all the dead load, live load, wind, and seismic. Okay, so if you're if you're on the Gulf Coast or you're close to an ocean, that's where your wind comes in, because of hurricanes and everything else. Seismic, that would be like California, that'd be somewhere in the West, where we have earthquakes. Dead load is what is just with the building just sitting there. That's all it is. So it's like a column that's just sitting there. How much does that column weigh? How much does the building weigh? A live load is going to be with the different elements involved. So think about it like in Dalton, it would be, so everything's been engineered for a snow load, which would be a live load. So it's when snow gets on the building, it adds extra weight to the building. So that's what they call a live load. Obviously, you distribute the points of the columns. It provides a fixed or level datum. So again, datum is what we talked about with that's like your benchmark, right? That's where you start. So by providing the slab on grade at the correct finished elevation, it gives you a brand new benchmark. So when we pour a slab on a car wash, that's at elevation 100, and now that's our new benchmark, is that entire slab. Slab. Everything related to that building is measured off that slab.
Okay.
So then anchors, they have wind load, which is uplift. Basically, think about it like Wizard of Oz, right? Whenever Dorothy got hit by the tornado, it lifted the building up off the ground. So they take that into account as well.
Okay.
And then any error here is expensive to fix. That's 1000% true. if we use the wrong size anchors, if we don't give enough, if we don't put enough anchors in, there's 1,000 things that could go wrong. And that's where it's on the superintendent to make sure as we're putting this stuff into place that we're following the drawings.
Okay.
So PM responsibilities before the first pour, obviously geotech review, we've done that, during pre-construction. We should have done that during pre-construction. It never hurts to read over it again. Any over excavation or backfill is documented. Proof rolling, of course, is all documented. So you've gotten all your sign-offs, all your compaction test is done. And then your footing bearing elevation, verified by the surveyor. Never assume grade is correct without data. So this is where we would preach on the car washes that once you get it formed up, guess I closed that out. Yep. So once you get it formed up, you go and you survey the center of the base plates. I'm sure you remember me talking about that 1,000 times. Let's see if we can find a decent photo of somebody doing it. Probably not, but well, that brought up all kinds of stuff, didn't it?
Yeah. And now, would this be something that the superintendent would do, or would you get a survey company to come out there?
No, we always get a survey company unless, like in West Bridgewater, Nick has our total station. So he will actually take it and do what the surveyor would do. But essentially you're going around. Now, not all of our base plates are going to be marked like this, but that gives you a good representation of what we're going to be shooting for. So they would go around and survey they would put their they would put their machine right here, their grade rod right here, and survey to make sure it's in the right place.
Okay.
Let me look at, and some places they require you to have a form survey. Actually, the municipalities will require that. Form survey. Let me look here. Which would be proof that so what they will do is they'll come out, let's just use this example. So they've got this formed up, say it's ready to roll, right? They don't have rebar in there yet, which is fine. They don't need rebar. So what they're going to do is they're going to come in and shoot all these corners. And then they're going to take that and they're going to compare it to whatever the foundation, this happens to be a survey, but whatever the foundation plan said, they're going to compare it to that CAD drawing and make sure we're laid out in the right place. Is what they do. So like on our car washes, they're going to take that column layout drawing that we got, and they're going to compare that to exactly what we have in the field. So if we go to our structural drawings real quick for West Bridgewater. Oh, well, hang on. We're making a mess here. Let's close this out. Don't save it. Okay. So what we have asked for on West Bridgewater is going to be this file right here, which is going to help us pinpoint all of these column locations. Okay, right here. So these are called column lines. So at the intersection of 2 and A, you're going to have the center of this column right here. So that's basically whenever we're talking on the phone or whenever you're talking to your superintendent, y'all are looking at drawings, if we're not sharing screens, then he'll say, okay, no, I'm talking about column line 3H. So you look down and you're like, okay, 3H. Well, then that's right here, basically. It's where it's where they're talking about. Or they can just say like column line 1. Well, that's going to be the exterior of the building in this case. But the thing you have to pay attention to very closely, and they have to pay attention to this in the field, because if somebody's not watching, they're going to look at this drawing. Think about this. This is say you got 4 guys in a hole that are out there trying to form this with a bunch of paper drawings, right? And they're looking at this and they don't see that this is not lined up on the center of the column. We have done this before. So that's why the anchor, the base plate survey is so important, because the center of this base plate is right here. Well, that didn't help. Is right there. Okay. But if they're looking at this in the field, they may look and say, okay, well, from center of base plate to center of base plate, I need to be 120 foot. So that's what they start laying out. Well, if you look, 120 foot takes you all the way to right here, not right here, which is the center of this base plate. See the difference?
Yeah.
So all of a sudden now, instead of, so if they lay that out wrong, then we've added, we'll just call this 4 inches. Maybe this is 4 inches here. And then over here is another 4 inches. So now all of a sudden our columns aren't going to, our structure is not going to fit together. It's going to be 4 inches off in both directions. So that's why, and here's another example of this. This column line doesn't line up with the center of this column. Now, isn't that confusing as hell, right?
Yeah.
So that column line is, the center of this base plate is actually somewhere in this neighborhood. I actually couldn't really tell you where that is right now without CAD. So that's why it's so super critical to get it all surveyed before we pour.
Okay.
The worst thing a superintendent can do is pull a James Gray and survey it after everything's poured. So.
Oh, I didn't know he
defeats
did
the
that.
purpose.
I see. He wasn't coming to mind, but I think it was our friend in Danville before the guy that ended up finishing it, Jonathan.
Yeah.
There was a certain time whenever, I think maybe on meetings you had said, well, have the surveyors gone out? Have you kind of looked at it yourself? And he was like, oh no, I haven't. I'll do that today. Then the next week, have you actually done it? No, I haven't yet. I'll get it done. And so I just remember hearing at that how important it was. And even if there's time from the time that the surveyor can get there, at least making sure on your end. I think maybe he had one of the cameras that could, if I'm thinking of it correctly, he had something on site that was useful and he was not using it.
Yeah, so we do provide, so there's two things. So there's a total station that we don't provide because it's like what the surveyors use. It actually takes a CAD file. So Google total stations and you'll see exactly there's some good videos on. But what we do provide for everybody is the laser level.
Yes.
So
that's what it was.
Yep. So if you've got a rotary laser level with grade rod, you don't need a total station. So we provide, this is exactly well, it's not this brand, but this is exactly what we provide to them. They set this up on the benchmark, they shoot the benchmark, and now we're able to go and actually look and determine. So this works for elevation, for height. It doesn't work for like if something's in the right place, left or like on a horizontal plane.
And
this
that must
only
have
works for elevation.
Yeah. That must have been what it was, but I just remember you had said like it is in the job trailer, go out and use it, and he never did.
Correct. For those of you listening, that's the quickest way to get fired from a job too, by the way. So
yeah, we have lots of stories to tell. So
oh goodness. All right. So let's talk about we're going to get into the schedules now, kind of what the schedules look like. And this is a pretty good example, except obviously it's not going to be color coded or whatever, but it's going to give you the footings. It's going to give you the footing number. It's going to give you the size, the depth, top of elevation. Okay. This is so it's -2 foot. So what does that mean to me? Well, I know that my top elevation is also my finished floor. All right, my FF and E. FFE, it's not FF and E, it's FFE because FF and E is something completely different, dealing with architectural stuff. But So finished floor elevation. So I know that footing number one, F1, is 2 foot from the top. So if my finished floor should be 100, right? It's always 100. Your finished floor is always 100. Then I know that the top of this footing is going to be 98. Something super simple that the superintendent can verify. This particular one also gives you the PSI, and then it gives you the rebar mats. So this is the different. So they want 4 number 5s at 9 inches on center. So that's going to be. Let's go to rebar mat 4 number 5 at 9 inches on center. Oh, that's okay. That's our shit's never going to be that complicated. Well, I won't say that. It very well may be. It's not right now. So here we go. So this would be let's just say that this is say these were single pieces of rebar. So if we were, so it's number 4s, 1, 2, 3, 4, and then the opposite direction too. It would be 9 inches on center. So it makes a grid is all it does. That's all it's doing. And that would be the same thing as what it's telling you. Let's see, this gives you a dowel. Let me look here. Number 6, number 4, a continued bond beam. This is actually for, here we go. 3, number 4 continuous, and number 4 transverse at 48 inches on center. So that's a fancy way of saying that they're, think about that as like a rebar mat. I need to Google. I haven't heard the word transverse in quite some time. So number 3, and I think that just means the opposite direction is all that means. Again, sometimes they make it more complicated than what it really needs to be. But so you should have a footing schedule on most of your drawings. If we go back to this structural set, because these should be the most common of what we're looking at. And then we've got I've actually got an example that I put in here later. But here on the main foundation plan, this is, you can see it's a much narrowed down version, doesn't give you a whole lot of information other than it does give you the footing number, the size of the footing, and the actual rebar. So this is number 5 bars at 6 inches on center. EW is each way. So that's boop, boop, like that. And at the bottom. So then you can get so depending on how tall that footing is, this one's only 1 foot. You would look at the actual section view to see what it actually looks like. So here's our footing right here. And then this is why they do the schedules or the tables, because they're just going to put a note here that says see footing table. That's it. So now you got to look and say, okay, well, this is a typical for P2 and P3, which is your pier cap, which is different than your footing. So this is the P2 and P3 is what they're talking about right here. But in this particular case, there's only one rebar mat. It's not top and bottom, according to what I'm seeing here. So I see the J bolts that are here, which is rebar. I see the rebar that's in an L here. And then it's tied to the rebar mat that's going to be wherever it is located per the footing table. All right, so a lot of information here, but the good thing is that a lot of this is kind of regurgitated on several of these details. So like here's going to be a lot of the same information. You'll just need to be sure to read through it and make sure that it makes sense. And if something doesn't make sense, then obviously we Google it or we ask a question, but all of this has been determined because of that geotech report and because of the size of the building. That's the structural engineer's job. So you can see that this one's a little different. They want extra reinforcement at the top of the pier. And then they have standard reinforcement all the way down through. So number 3, tie located no further than 1/2 the tie spacing above the top of the footing. See the pier table. Um, so let's see, no further than 1/2 the tie spacing above the top of the footing, see pier table. So no more than, so if it tells you to space this in 12 inches, then this would be 6 inches for the bottom one. Does that make sense?
Mm-hmm.
Because it's no further than 1/2 the tie spacing. So on the footing table, it'll tell you for the, or on the pier cap table, it would tell you that these are to be spaced, call it 1 foot apart. Then what this is telling you, then this one right here, because it's closer to the bottom, is going to be no further than 6 inches because it's no more than half of whatever that spacing is. So little confusing, but it'll make a lot more sense once you start kind of seeing, digging into it and seeing exactly what you're looking at. When you get a set of rebar drawings, shop drawings, they're not going to look like this necessarily. So what they're going to do is the company that's providing the rebar is going to go through and take like all of these pieces. So this is called a 90. So they're going to show like one of these and then give a quantity on it. Then they're going to show, see, this one doesn't have as long of a leg. So that's going to be another one that they're going to show. And so they're basically going to show each one of those and show the quantity and show how long they are. And that's kind of how they would go and construct this together.
Okay. And then as the PM, you would need to confirm the quantities, right?
Yes, I would, so that's where I would use AI to help me.
Okay.
Because it's going to be, because if you try to do it with paper and pen, it's good to do it for like one time, but it's going to be very time consuming because you have all of these different footings that you need to verify. So what I would do is put this into AI and say, give me a detail on the rebar that is shown for this footing right here, like a detailed breakdown, like list out for me. How many of these should I have? How many of these should I have? And then you can take that and compare it. Or once it's done that, then you upload the shop drawings and say, okay, now that you've done that, compare it to the shop drawing submittal that I've got.
Okay.
And let it work its magic. And then once it spits it out, that's when you're going to take it and compare it and say, okay, it originally said we were supposed to have these. And of course I would go and spot check, right? So I would go and spot check like maybe the 5 and the 6. I would spot check these two to make sure that it did it actually correctly on the original count, and then you can compare it to the submittal drawings once it spits out the data. So that's something that you can use AI for. That's going to help tremendously on all of this. But you can see here reading this that these are so your F4s are there. There's an F4.5. There's an F5. There's an F5, F7, F4. So, basically it's saying I would need to dig into the drawings a little bit more to see what it's talking about here, because I've got this one pointing to here and I've got this one pointing to here. So I would need to do some more digging to try to figure that out. And then, but that's not to be confused with the P's, right? So this is the P4, which is going to be your pier table. Okay. And the difference in those two is going to be right here. So this is footing right here. This is pier right here. That's your pier cap.
Okay.
Okay. Very important because pier means something completely different. You would actually do, so in in concrete foundations, you've got footings as your very bottom layer. Okay, that's the first thing. So that's what's in contact with the earth. Then you've got piers. Okay, so sometimes instead of doing a spread footing, which is what this is. So a spread footing is basically 4x4, 5x5, whatever, 4.5x6. That's called a spread footing. It spreads the load. Sometimes it doesn't make sense to do these, and it's cheaper to actually drill a pier. So you would actually drill a pier that was really deep and would have a rebar cage in it. And you wouldn't have a footing, but this would be like say a 3-foot pier. So think about it like light pole bases. We drill piers to do our light pole bases. And essentially it would so it's a circle, is the best way to think about it. Most of the time, you will not have, in the projects we do, you will not have square piers. So when you hear the word pier, it's always a diameter. It's either 2 foot, 3 foot, 4 foot, whatever diameter, where they auger down. Then they may put a sonotube in if the soil is not compact enough. So because you're always doing these in typically native soils. You're not doing them in something that's been structurally filled or anything else. Okay. So like I said, using the analogy of using the light pole bases. So that would be that's the part you see, right? So, and the light pole sits on top. So the part you don't see is underground. So it would be something like this, basically. Not to get too detailed, but this would be called what's a bell. It's called a bell on the bottom of the pier. So, which goes back to uplift. It helps keep that pier from pulling out of the ground when you have this little bell on the bottom of it. But so sometimes you have to put the sonotube in place, and all that sonotube is there is to hold the concrete. Hold the concrete, hold the anchor bolts if you've got them in there, and in that way it doesn't move on you. So we do most of our stuff because it's smaller buildings, and smaller buildings, it's not cost effective to do piers because you have to have many more of them, and it's more cost effective to do the spread footings. So that's why on our buildings that we typically do, you'll see these details way more showing the spread footings than you will actually piers in the ground. All right. Does that make sense? I don't want to confuse you there, but
yeah,
okay.
it does. Well, and on one of the videos, if I'm thinking of it being the same, in one of the videos you sent, it showed the Burj Khalifa and all of the rebar, and it talked about what would happen if it was not, if you just kind of let it sit there, it would fall over and crash. So anyways, seeing that and basing it off of that video, it's making sense.
Okay, perfect. Good. All right, so then we'll go through. So and this is just, we're not going to go through examples on all this because these are pretty good. These are pretty good layouts here. Now, I will say that this is a lot more information than they typically give you. This would be like an ideal situation because it looks like all the information you need is actually here. But anytime there's a question on anything, you can always refer to this happens to be a pier schedule and column schedule. But you can always refer to it, and it will give you exactly what should be in the ground. Okay. Vertical bars, critical PM check. So yeah, your bar count versus your size, your splice length above the footing. So splice length is anytime that you've got, it is anytime that you've got an overlap of the rebar is known as a splice. So like here, let me give you a little better example. Right here. This would be a lap right here because this rebar is overlapping these bars that are running the opposite direction. And then it would be tied together. That would be a lap.
Okay.
Or sometimes if you have a mat, so a rebar mat, which is in your slab on grade, right? So if you have, rebar comes in, basically you can get it in 20 or you can get it in 40-foot lengths if you want it, but most of the time we see it in 20. And if you want to tie, here we go. So if you want to see, these are spliced together. These are not spliced. These are just the mats. But if you had two of these come together, you would have an overlap. And I don't see one there. Let me look here. I'm sure there's one here. I just can't see it. But anywhere you would be splicing two pieces of rebar together, the distance that they overlap each other would be called the lap. And it's specified. So it's usually 18 inches, 2 foot, something like that, but it will be specified on the drawings on what the lap should be. And then of course, photos, that's a given. Your superintendent ought to be taking photos of absolutely everything. So tie spacing. So this is kind of where they talk about the rebar being spaced differently. So where we've got where that would be like the on center. So when it tells you, okay, these are going to be number 3s and they're going to be tied every, 6 inches on center. So that's every 6 inches, you've got a bar going. And then of course, missing or misplaced ties. So the tie, when they talk about ties, that's actually the piece of wire that is tying the rebar together. It's literally a tie.
Okay.
That ties it together. So that's what this guy's doing right here. He has a rebar tool and he's taking that piece of wire and it ties those 2 pieces of rebar together at that intersection. There's another good look at it. So these are rebar ties right here. And that's basically what holds it all together. All right. So this would be more of like a shop drawing. This is where you would see this. You're not going to see this a ton on most of our drawings that we do, or most of our projects, because they don't go into this much detail. No, none of the engineers spend this much time going through the detail. But this actually calls out whatever number they've given it, and then the bar size, whether it was a straight, whether it was an L hook. So an L would be that. I mean, it's exactly that, an L. So that would be something. An L you automatically know is like from a footing to a foundation wall, or it's moving from one piece of concrete to the next. That's what an L is for. And then they give you the total length, but this would be part of your shop drawings. That's what you need to remember here, is this is actually part of your shop drawings that you would upload to AI and use to verify. So here's a detail that I pulled out and put together. We basically just went over this, but it's just to give you a visual representation of what we're going to be looking for. So again, we're going to confirm the rebar size, confirm your dimensions. This should be done by the superintendent. He's determining the cover, right? The amount, making sure that the cover is correct. Obviously, because if you put rebar too close to the edge or something, it obviously has a chance of corroding. And if you've ever seen, so we see this a lot in parking lots. If you look in a parking lot and you look and you might see a piece of, it looks like rust that's on top of the concrete. Well, concrete doesn't rust. So if it's rusting, then that means that the rebar is too close to the top and is actually probably partially exposed if you look at it. Because they had that mat that was either the rebar or the mat was too close to the top. And sometimes, because it's not straight, right? Sometimes that rebar is, especially the wire, is going to be a little wavy. So that's why you got to make sure that it's far enough down that you get complete cover. Anchor bed locations, we've talked about that, making sure that we survey those. And the other important thing about surveying the anchor bolts, and I try to reiterate this as well, is if the surveyor comes up in real time and says this base plate's in the wrong place, we don't just move it based on the surveyor's recommendation. We go back and we pull dimensions. We pull and see where the problem is, because that surveyor could be wrong too, right? His machine may not be calibrated. It could be in a different scale. There could be several reasons that it's off but it's not actually off in the field. So we always use just like we use Bluebeam to kind of check dimensions. We don't ever lay out based on it. We use it to check. Same thing with the surveyor. It's used to check. So if there's something wrong, then we kind of go back to the drawing board and figure out, okay, what exactly happened here? Because odds are, if they measure where something will compound is if they take, let's go back to here. So back to our example here where we were off, the center is off, right? So if they use this pier, if they put this in the wrong place and they use this to then measure everything else, all of these may be correct from like pier to pier, but overall, by the time you get to the end, you're going to be wrong because you didn't start at the correct center point. Like if you started there instead of actually starting there to lay out, then your entire layout's going to be wrong, the whole thing. So let's see here. All right, this is just kind of a drawing exercise that you can kind of go through and use. Like I would pull a couple of drawings to use just to kind of go through some of these, just to kind of well, you probably to answer these questions, you probably need to use these, but because that's what they've given you to kind of look at. But like you're ordering rebar, so you're not going to be ordering rebar, right? Maybe you're checking a rebar shop drawing. For column C3, how many vertical bars do you need and at what size? What dowels must you spec on the footing? Order to match? Footing order to match. That doesn't really make sense. So, but in any event, so let's look at our column schedule. So we're ordering rebar for column C3. So this is going to be C3. It's 16 by 16. It's got 6 vertical bars. They're number 8s, and our ties are 4 inches. And then our tie spacing is every 10 and 6. So basically this is going to mean that, so the vertical bars that we're going to need are going to be 6 is how many we need. And they're number 8s. All right. Which are going to be basically 1 inch. That's going to be some big old rebar. The ties are going to be, so the tie size doesn't go by 8. So it's not going to be a 1/2 inch tie. I don't know exactly what, I'd have to Google what the tie size is, but, and then your spacing, 10 and 6. What dowels must you use on the, so if it's 10 and 6, what I would do is take this and throw it into ChatGPT and tell me what does 10 and 6 mean. And that way I would get educated on it because I don't know, to be honest.
Okay. Just based off Google, it says for number 4 rebar, the most common tie size is 4 inch to 5 inch.
Okay.
So.
All right. That makes sense.
That helps, but.
Yeah, I'm not sure what this tie spacing means here, but again, we don't have to know all this, right? I mean, it's good to know. Trust me, I wish I knew what it was, but I can Google it and figure it out. So not that big of a deal. I would just I would want to make sure that I knew it before I got to the job. Probably what they are square. So yeah, I'm not sure what the 10 and 6 is because it is different than them being on center. So if they're 10 inches on center, that's, both ways, that's pretty simple. It'd be 10 and 10. So footing F2 is being formed. The crew has set chairs for 1.5 inch cover. Is this correct? What does the drawing require and why? So footing 1 here, footing 2 is 4'6" by 4'6". The depth is 14 inches. This is going to be the PSI, is 3,000. And they want number 5 bars, 9 inches on center. And then we've got has set the chairs to 1.5 inch cover. Well, that's going to be incorrect because we want 3 inches of cover from on the chair height. We already know that from what we talked about. And what does the drawing require and why? So we would have to look at our detail for that. But in any event, so you can go through the rest of these questions when you have time. Not a big deal, and just kind of gives you a good overview.
And so for the chair, the 3 inch, it's just always, you think just rule of thumb, always go with 3 inch.
Yeah, it's always 3 inch.
Okay.
Yep, it's always 3 inch. That's the industry standard. So you could probably get 1.5 inch chairs, I guess. I don't know, but we always use the 3 inch.
Okay.
All right. So PM checklist. So pre-pour, sub-base compaction reports on hand. Obviously, that's, we've already got those well ahead. Your vapor barriers installed, lap 12 inches minimum. So again, lap means they got one piece of vapor barrier, they got another piece of vapor barrier, and it has to overlap by 12 inches. Okay. And taped. Make sure it's taped. No tears, obviously. Defeats the purpose of a vapor barrier when you got a tear in it. Rebar or welded wire mat is placed per plan. Chairs are at the correct height. Anchor bolts templated and verified to structural layout. Okay, that's why Modern Wash provides us on their buildings. They provide us with the base plate templates, and then so we look at exactly where those need to go based on They actually provide us with a column layout, which is going to be right here. So they provide us with all of these are so CB should be like CB1, CB3. See, each one of these are called out different. If you look back at this page here, this tells you what a CB1 is.
Okay.
Yep, there's CB1, CB2, CB3. It gives you a section view and also gives you a plan view right here. So you should know that if you're looking at a job and you can automatically go on the job and just kind of look, okay, I already know that all of these along this wall are going to be, well, we got a mixture. So CB1, CB3, here are CB2s, and then we've got CB3 here, a CB3, a CB1, CB1, CB3. So if I walk on the job site, or more importantly, I get a call, right? You get a call from your superintendent that says, hey, we don't have enough CB2s on this job. We don't have enough. And you're like, well, how many do you have? Well, I've got however many. And then you're like, okay, well, how many are we supposed to have? Then you can go on here and look them up. And maybe they didn't even look at this and say, okay, well, maybe they're assuming that these are CB2s and maybe, I don't know, these are CB2s, whatever they're assuming on site. But the point is that you can, anytime a superintendent calls with a problem or with something that we're missing or something that we need, we always double check the job site and then you verify it against the plans. They do not, Modern Wash does not give you a quantity on these. So something that I always do every single time is I will take the plans in the job trailer and I will go through and I will count. I will highlight and I will count up each one of these base plates. And then I would go back and I would write it on this page. That way, when the base plates come in and the anchor bolts come in, I know exactly how many anchor bolts I need because I can see here, right? There's one per of these. There are 8 anchor bolts in the CB2s and there are 4 anchor bolts in here. So I would do some simple math. That would tell me how many anchor bolts I needed. I already know how many base plates I need. That way, when that information comes in, I can go out there and I can count it. I won't just throw it in the job trailer or just throw it in the Connex and never worry about it until the day we get ready to pour, or until we start setting these. So that's something that's for you to verify with your superintendent. Or what I've done on site too is I'll show up and I'll be like, where are your base plates and your templates? Have you counted them? No, I hadn't counted them yet. All right. That's going to be a good activity for us this afternoon. And we go into the or we go into wherever they're stored, we bust them out and we count them. I actually physically do it with them. And that does 2 things. It goes a long way, number one, and also shows them if I'm willing to count them, then you sure as hell better be as well. So let's see, cold joints approved. So cold joints we talked about, right? That's anytime that you've got if your plans don't specifically call it out where a cold joint is, or whether it's a cold joint or a monolithic pour, you'll need to pay attention to that. Goodness. There we go. I do want to show one example. Let me make sure we stay on time here. We're still good. The most obvious example I can give you of a cold joint is going to be on our trench. See here, here we go. All right, so all of this is drawn to be monolithic. There's no joints in any of this. There's no joints in any of this that I see. But that's not the way we do it. Like there's no way to pour this trench and get it right if you do it all monolithically. So what happens is we have a joint here. So they would pour this bottom first. All right. Then they would pour, then typically they'll form this up and they will pour this second right here. And then most of the time, they'll pour that. All right. So for a trench, you have 1 pour, 2 pours, 3 pours, and then a 4th pour for your slab on grade. Okay. Now, those are all cold joints. Every one of those is a cold joint. That's where most concrete subcontractors miss this note right here. Where trench wall and slab are not poured monolithically, install a PVC water stop or keyway. Keyways, we don't do a ton of, so just make a note. You can Google, find a video on what a keyway is. But it's essentially a keyway is meant to keep 2 pieces of concrete, like concrete's going to move, right? So it kind of, it helps to keep it from, if it's going to crack, it controls the cracking, and concrete's going to crack. There's 2 things concrete does, and it gets hard and it cracks. That's it. But so they need to have water stop. That's the important thing with this note. Install PVC water stop in a keyway. So water stop would be installed here, would be installed here, would be installed here. Okay. When we first started doing car washes, I had to Google what a water stop was because I had no idea. There's a couple of different types of water stop. So like we did this in the Northeast. They actually installed like they put down caulking and then they put down a piece of tape. It's like a foam tape. What happens is when this tape gets wet, it expands. And so the first time it gets wet, it blows up on you. This is a traditional water stop right here. So basically it keeps water from moving from this portion of the slab out into the earth. It's what it does. It literally stops the water. You know, a lot of our acronyms are pretty easy that we came up with or a lot of our terminology.
Yeah.
Right?
Yeah. I will, for a second there, you're going to actually, I was embarrassed. I didn't know it. I think it was before our first meeting, it was stormwater.
Mhm.
And I was like, well, is stormwater just water that comes from the storm? It was a whole thing. And I was like, okay, that's embarrassing. But then like, there's some things like when you were saying the ties, the rebar ties, like, you know, it's actually a tie.
Right.
You know, so.
Yeah.
Yeah.
Yeah. We get real technical here. So
Yeah.
like I said, we're not building watches, right? We don't need to overthink it.
Yeah.
And it's a lot of moving. It's a lot of simple stuff, but when you put all this simple stuff together, that's what makes it complicated. You know, at least from the outside looking in. It looks like, oh my God, that slab just looks incredibly difficult. But when you actually break it down and think about it and look at the details, it's not as complicated as what it seems on the surface.
Yeah.
So during the pour, so real big concrete tickets. Obviously, every time you come in, every time a truck is delivered, that they have a concrete ticket, which we should be checking. And the testing lab will help with this because the superintendent will schedule the testing lab to be there because they need to take their breaks, right? And that's how we tell the strength of the concrete that's been poured. It's got your slump, which is from your specs, right? And that's how the way I think about slump. The guy did a pretty good video. That's almost exactly how it's done every time in the field. Is they have that cone, they put it in there, they put they stab it with a piece of rebar, make sure it's vibrated, so to speak. And then pull the cone away, and then they measure the slump. So how much ever that concrete literally slumps.
Yeah, he did that. I was like, I don't think that doesn't look normal. Like when I first watched it, I was like, that doesn't look normal. And then they're like, yep, this looks great. I was like, oh, great. Okay.
Yep. So if it's really wet concrete, then it's like so I've seen concrete that ended up being like a 9-inch slump. So it was so watery. And so, we ended up having to reject the truck. And that's what the testing lab will say, nope, this doesn't meet spec. And that's when all right, this truck needs to be sent back. Sorry. Maybe the concrete sat out too long. Maybe it took too long to get there. Maybe there's all kinds of stuff, right? and there's different additives and things that you can add to it, but we try not to add anything to the concrete unless we absolutely have to. So slump test, obviously make sure that it's and there should be a specification on how often we do it. We typically don't pour that many trucks or that many yards at a time. Usually about 100 yards is the most that we're going to pour. And so that would be, so you might do the slump test once, maybe twice. That's it. And then your breaks are typically taken, you'll take them at the very beginning. And then there's typically like you'll take them so each truck, might hold 9 yards of concrete, something like that. So maybe every 5 or 6 trucks, you take another sample or the testing lab does. And they put this into cylinders, which, yep. So they'll put these into cylinders, and then this is exactly what it'll look like. Well, except these have already been taken out, but they'll put a label on them, and then they will set them by the job trailer or set them somewhere where they're not going to get damaged. And then they'll typically come back the next day and pick them up.
Okay.
So then your concrete is going to be broken typically it's breaking at 7 days. It's breaking at 14 days, 28 days, and maybe even 56 days. Okay. So you got to have that many samples, right? So if you're breaking one at 7, if you're breaking one at 14, if you're breaking one at 28, and you're breaking one at 56, that's typically 4 samples that you'll need. Something to keep in mind is that I think it's like 80%, like concrete will gain 80% of its strength in the first 7 days. So if you've got a break at 3,500 PSI and it breaks at like 3,200 your first 7 days, you're golden. But if you get a sample and you get a report back and that 7-day break is 1,200 PSI and it's supposed to be 3,500 PSI, at the end, then it could be a bad cylinder or it could have been a bad concrete batch that we had. So then we break it. We can either make a choice now. Okay, we're going to take that 56-day break and we're going to go ahead and break it now. Let's break that other one and see what it is. And maybe it turns out that it ends up being 3,000 PSI and you're like, okay, it was just a bad cylinder. Or if it breaks the same, then you're like, okay, we've got a problem. We need to figure out what we're going to do. So then we would do an RFI to the structural engineer, and he's probably going to tell you to take a core sample of whatever you poured. Okay. So that'll be something that we can get into if that happens, but that's kind of what you're looking for on concrete breaks. Vibration spacing. So anytime that concrete is poured in any type other than a slab, actually slab too. Yes, definitely slab. What am I saying? Let me show you. This will be a good representation. That'll make sense. So the reason that you vibrate concrete, and you'll see it done several different ways, but this is a pretty common way. So basically it's a airline that has a vibrator on the end of it, right? And it's hooked up, either air or I guess electric too. Maybe electric. I don't know. Anyway, but they stick it down in the concrete and it vibrates it literally shakes the concrete. And the reason it does that is because you want to get the aggregate. So sometimes when a concrete's poured, the aggregate doesn't really settle quite right. And it will help spread out, make the aggregate and the cement, because those are the 2 pieces of concrete, right? You got cement and you've got rock. So you cannot have concrete if you don't have both of those things. And the rock is also known as aggregate. That's another word for it. Okay. So, but it vibrates both of them together so that they come together and they're a little bit closer in their spacing. One way to obviously tell after it's done, and I would encourage you to look up, I didn't send videos on concrete vibrating. I should have, because it's very important. You will, yeah, if you look at the edge of a slab and you can tell that it wasn't vibrated properly because it honeycombed. Um, that's called honeycombing. So that is a clear indication that concrete, it was not vibrated right. The cement did not mix with the
Okay.
aggregate correctly. And so what's happened is, and you'll see this a lot on curbs, on the back of curbs, because it's difficult to, like, you're not going to vibrate the back of a curb. It's not, it's not as critical. Where you don't want to see this is a good example. That was clearly not vibrated. That's a problem.
Ooh. Yeah.
So that's why it's very, very important. Now, if you're in Texas and this happens to be probably like a bridge column or something like that, where they actually had it formed. But that's why in Texas, you have to physically make sure that they vibrate it, Texas or wherever you're earth forming, because once they pour that footing, you're not going to be able to see the edge of that concrete. So that's why the superintendent has to make sure that they're vibrating the concrete.
So then what would you do if that happened in that case?
In this case, you would do an RFI, send a photo, ask the structural engineer, and the structural engineer is probably going to tell you to tear it down. Most likely. So that's a pretty rough example right there. That's pretty bad. I would say that's an extreme example. A lot of this, you'll see a lot of this on like some of our edges, some of our corners of our slab. You'll see this from time to time.
Okay.
Typically, if it's just, if it's a little bit, probably not going to be that big of a deal, right? You're never going to get it completely smooth like this. Yeah, I wouldn't worry about this too much. But you don't want it any worse than that. Okay. Yeah, that's just awful right there. Whew. It's terrible. But anyway, that's vibrating is super, super important. Weather watch. So if it's hot, so that's why we, they make fun of us in the Northeast because when one of my first projects up there ever, I was like, and actually Ron talked about it as well when we were in Pittsfield, but the concrete guy was getting ready to make his first pour, and they said, okay, well, we're going to pour. We're planning on pouring about 2:00. And he said, well, is that in the morning or is that in the afternoon? And he was like, are you kidding me? We pour in the afternoon. And he's like, well, in Texas, sometimes we pour at 2 a.m. because it gets so hot here so early. And the hotter it is, the quicker that concrete's going to set up on you, and then you won't have a chance to finish it correctly. So,
okay. I think some of the car washes we've had to do more 2 a.m., maybe not 2 a.m., but definitely early morning pours. So that makes sense.
Yep. And also you don't want, the concrete's hot too, right? It's when that sun comes out, it's going to be hot, like physically hot. Another reason they do it is the guy, that way when they're done, they'll be finishing it maybe 10 or 11 o'clock in the morning, and it hasn't gotten to the heat of the day yet. So your guys won't pass out on you, so. All right. Then post-pour curing compound applied immediately after finish. If you have a curing compound, that's in the specs. If you had one, any control joints. So on all drawings, they're going to show you, there's going to be a note talking about a control joint. Again, a control joint is just that joint that helps control the cracking. Not to be confused with an expansion joint. So control joints are just the little saw cut that's made, like right here. Just a little saw cut that's made. That's a control joint. An expansion joint is actually typically where you have two slabs meet. So it's a cold joint, right? But you also want to have, but it's made for expansion. So you'll see them put like little pieces, little pieces of plastic. I hate the plastic ones, but sometimes they use plastic. Other times they just use this is like an OSB type board. that they'll put in there in between the two pieces of concrete. That way, that concrete's going to move like this. It's going to move like this, and that expansion joint kind of helps it not keep from cracking and busting up.
Okay.
But the saw cut is what's done. Let me snooze that real quick. But a saw cut is for a control joint, and that, like I said, control the cracking is exactly what that's for. It'll typically crack from control joint to control joint, or it won't necessarily crack at all.
Okay.
But concrete always cracks. So, floor flatness, levelness. So that's obviously, we got to make sure that our elevations are correct, depending on the slopes. So that's clearly, super, super important on our car washes, because this right here, they've got these elevations here. And that is all to make sure that, so I can look at this and tell you that this is telling me that elevation right there. This is telling me this elevation right here in the corner. So I know that this slab is sloping that direction. So it slopes all the way to there. And then we're sloping from this direction. We're going to slope this way.
Okay.
Or we should, anyway. All right. So, and obviously this is all at elevation 100, except for, which you'll find a note. If floor drain is desired, slightly slope concrete to drain, coordinate quantity and final location with owner. That's basically one big cop out. But we know that in our equipment rooms, we typically have a drain here and a drain here. So we're going to be at 100 on the exterior of this, and then we're going to slope to the drain. So this would actually be sloping this way. Probably we're going to slope it that way for this one, and then come in here like that. So it all slopes to the drain. Not a super slope, maybe like a 2%, actually probably like a 1%. We just wanted to slope, just a gentle slope to the drain itself.
Okay.
What you will run into is, like we've had on the car washes, if this is our drain, then they only slope it, like, say, in an area about like this. They only slope it that much, and then all of this ends up being 100. So if we have a spill over here, it never makes it to the drain.
Okay.
So that's why it's got to be a steady slope all the way from the corners.
Okay.
7-day breaks. We just talked about that. If you're having a 75%, so instead I think I said 80%. So you should have 75% of your total break. So if it was 4,000 PSI, then you should be breaking 4,000 times 0.75. You should be breaking it at least 3,000 after 7 days. And then 28-day breaks, that's the official breaking. So you should obviously be at 100% or more of that by that 28-day break. All right. Goodness. Are you cool with going over today? You got anything to do?
No, I'm good.
Okay. I have not done a real good job of keeping track of our time, and we are way off. So, all right. So let's just keep going. All right. So talking about anchor bolt layout, which we've already talked about, extensively, or at least a little bit. So most of the time on projects, your anchor bolts are going to come with your steel. Okay. And whoever's fabricating your steel columns will fabricate your anchor bolts as a general rule of thumb. Okay. Here's why that's important. Most of the time, so say if we have, like, Modern Wash is a great example. Not Modern Wash, the metal building manufacturer. So if there's somebody that we're using a pre-engineered metal building, we don't need that building for, say, 3 months, right? Because we got a lot of work to do. But we need those anchor bolts like maybe a month into the project. So that's where we always make sure we get those. That's another important thing with you getting your submittals done. because they won't put those. Sometimes those anchor bolts are stock, sometimes they're custom manufactured, but they will not put them into production until they have a shop drawing. Well, sometimes the steel shop drawings take forever to get done between revision here, revision there, da 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 da. That's one thing we don't really have to do on the car wash buildings that we do for Modern Wash, because they are also the engineer. So there are no submittals when it comes to their building. Okay, so that's a little bit different. But you want to make sure that those submittals are approved, because you're going to need those anchor bolts earlier. Okay. And then typically the concrete contractor will always set the anchor bolts, because they're responsible for setting them in their footing, right? And that becomes a problem sometimes, because if you have a ton of rebar, which we do in most of our then it becomes difficult to be able to put those anchor bolts in there and have room to where they're actually straight. That's why sometimes we end up with anchor bolts like, off to the side, whatnot. Yeah, so that would be a good example. You've got that's not a great example. Here we go. Maybe that's a better one. Well, other than it being poor resolution. There we go. That's a decent one. So that's a little different type of base plate. But what they've done is they've set them in place, and then they've taped the threads on the anchor bolt so that when they pour the concrete, it doesn't get all messed up.
Okay.
That's something that's very important to do. You want to be sure you tape the threads on the anchor bolts. Here's another example where they've got them taped. They've got this suspended inside the footing or inside the pier cap or whatever this ends up being. And you can see that these are straight anchors here. Sometimes you'll have straight. Sometimes you'll have, like, see, these have a nut on the bottom of them.
Mm-hmm.
Okay. That needs to be, they're very particular on the structural drawings on what you need. If it's an L, it's either going to be an L or a J bolt, or it's going to be a straight anchor with a nut on it. But this is very, very common. We do this all the time. Again, template and location check. So that's where we make sure that we're double checking when we have all that base plates placed, we're double checking to make sure they're in the right place. Then we also, you got to make sure that they don't move, right? So when they're pouring concrete, there's a little bit of force behind that concrete. So that's something else the superintendent has to pay attention to, is whenever they're moving or whenever they're pouring, that those anchor bolts, that they stay straight. You don't want to be done pouring and they're all out to the side. And then, of course, you have a final strip. So you strip the forms away. Typically, the day after you pour a slab or you pour concrete. So the big expensive thing here is there are ways to fix it. If you miss, like anchors on a base plate, if you miss something, you can typically core drill and epoxy, but we have to get that signed off by the structural engineer. So that's always done via an RFI. And then it's typically always a back charge to the concrete subcontractor if he had it in his scope to place those anchor bolts in the right place.
Okay.
Okay. The way that we do these, if the process is followed that we set in place, you will never have to. Never is a strong word. You will most of the time you won't have to. You should not have to core drill and epoxy or drill and epoxy any anchors, because we've surveyed the base plate and they're all in the right place. We would rather that the steel be wrong when it comes in. Mm-hmm. That way, because it becomes a monetary issue, right? Then somebody else is paying for it besides us. All right. So concrete ticket verification. Oh, this is kind of in the wrong order. So we should have talked about this when we're talking about concrete tickets. Okay. Well, I'll rearrange this PowerPoint, but this kind of just gives you, it's all the same stuff that we've talked about. You should have a mixed design number that's on your concrete ticket. You should have a PSI. This is basically all the stuff that the superintendent should be checking. Okay.
Okay.
Do a check on the first couple of trucks, and then do a spot check there and after. Um, Concrete testing. We have talked about this pretty extensively, talking about slumps. Is there anything you don't understand, I guess, about between slump or when they take cylinders and they take tests and they take their test cylinders?
No, it makes sense. I would say the only thing, but I think I might just, I guess like the 7-day break and 28-day break, I'm understanding it for the retesting, but maybe I'm thinking too far into it because we just would send that off,
Well, so it's
right?
always sent off though. So
Yes,
it's the testing lab is the one that does it.
yes.
So they
And
they're in their laboratory and they test it. So you're not
mhm.
really sending it off. You're unless you're talking about when you get the report back, then you're sending that off. Which one are you talking about?
No, I think I'm making it a little bit more complicated in my head of
Mhm.
just the break part of it, but we will have already poured so that's when you have the cylinders, you have your 4 cylinders, but your concrete is already poured.
Oh yeah. Yeah,
Yeah.
yeah. Because you're taking it out of you're actually taking it out of the back of the truck. So what they will do is like this is a guy that's doing it on site. So you see that wheelbarrow behind him?
Hmm.
So they don't ever they don't ever take samples directly from the truck into the cylinder. Okay.
Okay.
They'll take it and they'll dump it into their wheelbarrow because they're going to simulate also because a lot of times there's going maybe there's more aggregate, maybe there's more cement, whatever. Then they're going to take it and they actually mix it in their wheelbarrow. And
Okay.
then they'll shovel some in, and then they'll take that ride, which is typically a piece of rebar, and they'll stab it. And that's gonna simulate like a vibration, which is
Okay.
what the concrete contractor is already doing. But yes, while they're doing this, there's no testing that's done on site or anything. The only
Hmm.
thing that will be done before we pour is the slump. They
Hmm.
will do the slump test before we pour to make sure that it's good before we go ahead and pour it.
Hmm. Okay.
In the event
But
that we
you,
have to add, so if it's not wet enough, like maybe we've only got a 3-inch slump and it needs to be 5, they may add a little bit of water to it, and they'll let it spin a little bit, or maybe it's too wet, then they'll continue to let it spin, maybe not pour it yet for maybe 15 or 20 minutes. And if they do that, then that what was a 7-inch slump will all of a sudden turn into a 5-inch slump,
mhm,
because the concrete's already started to set up a little bit.
Okay.
It all has to do with the aggregate to cement ratio, the mix.
Mhm. Okay. But they're doing the cylinders and you just keep on pouring. You just do your thing. You don't let the cylinder or like the testing or anything stop you. You do
Nope.
it
You,
and
keep-
wait
you
for the
got it.
results.
You got it.
Okay.
You got it. That's why after the fact, if you have a bad break, that's where we end up going back. And so wherever you took that, so um, a report that they'll give you along with the test break, they'll tell you what it broke at, but they'll also tell you where that sample was taken from. Like which portion of the slab do we think it was actually
Mhm.
taken from?
Mhm.
And then we may have to go in and core that portion of the slab. And essentially, when we core the slab for testing purposes, they core it and you end up with a concrete cylinder, and they do the very same thing. They take it back to their lab and then they crush it just like this. They'll put it in a
Oh, okay.
press. Yep, they'll put it in a press, and then it gets crushed, and then whatever it spits out as far as the data, then that is, yeah, like when it actually breaks, that's when the machine stops and it tells you what the PSI was.
Okay, so it actually does break.
Yes, no, it gets broken.
Okay.
Yep,
Okay.
yep, just like this. Yep, that's more slump test, but yes, that is absolutely right.
Okay.
Um, let's see, air content. Again, that's going to be part of your mix design. Concrete temperature, that's the temperature of the actual concrete. Then you've got hot weather, cold weather. So obviously, anytime that's less than 40 degrees, You know, we have to do extra measures. Sometimes that's like concrete needs to be covered sometimes in order to maintain the moisture in the slab, because if it dries out too quickly or if it freezes more or less, so you've got water in the concrete, right? And if that water freezes in the concrete, it'll do what's called spalling on top. Let's see. Let me see if I can give an example. Yeah, so that's a pretty good example of what happens when you pour and you don't keep the concrete covered and it doesn't maintain the moisture.
Mm.
It turns out to be an awful, awful finish, and it also affects the structural integrity. So that's where when we get into it, like this particular one, they put down blankets after it was, I'm assuming this is after it's poured. It could be before it's poured. I can't really tell from the photo. And they're just trying to keep the ground thawed. But that's here's another good example of what happens when it's too cold and we didn't leave it covered. We didn't, you know, for whatever reason. This is them. So you can see the hot concrete. They're covering it so that it can cure properly.
Okay. So I guess with that, if it is still wet, it's okay to lay something on top of it.
Yeah, so it's not like wet. So like you could walk on
Mm-hmm.
this probably.
Okay.
And it might leave just a little indention on your footprint.
Okay.
Like you're not going to sink. It's
Yeah.
that, you know, it's that cured. It'll be
Okay.
like when it's as cured as it is when you have, so when a guy goes to,
Well, because I know we did this in Missoula and Billings. We had to pay for winter conditions, and I remember the concrete company would come out every night or whatever it was during that time and cover it, and then the next morning reheat it. They would do all of that.
yeah, so they were keeping the subgrade. They were keeping the subgrade
Okay.
thawed. And then once you cover it with the blankets, then you can run, actually you don't need, because the problem is it has to stay covered for like, a week, you know, 4 or 5 days. I mean, it kind of depends on the weather, kind of depends on everything else. But this kind of gives you an idea of, this is a concrete finisher. This is a trowel that they're using. So like, you know, instead of doing a hand trowel like this guy's doing, if you've got a big slab that you're pouring, you can use a machine. But you can see that the concrete's, you know, he's walking where, you know, he's not sinking. So that's how far, you know,
Yeah.
it's just literally that top, you know, 1/8 inch maybe of the concrete that you're actually finishing to give it a nice smooth finish,
Okay.
or a rough finish, or, you know, it all depends on what kind of finish you're trying to achieve. And they also make them to where they're like ride-on. So these are like ride-on machines here. So, but yes. Uh, all these look like what happens if, um, yeah, so see, they used them for, so here you can see that they're thawing the ground. So you can use blankets to kind of help keep the frost off if you're in the cold weather. But we would, like in Missoula or Billings, we would actually have lines, little 2 inch line, you know, like garden hoses. Think about them like garden hoses, except they're 2 inches in diameter. And they would run through what's called, you know, it would have glycol run through them, which would actually keep the area heated. And we'd throw a blanket over it, and it would keep that subgrade to where it was heated, because you don't want a frozen subgrade to interact with your concrete as well. So, um, again, only typically an issue in the Northeast. Um, hopefully that will not be a problem when we remobilize. So, because we'll be beyond all that. Okay, cool. Let's move on. Okay, so yeah, some more examples. Yeah, I need to rearrange these slides. I guess I got them out of order. But here you can see this picture here. These are using J bolts, very common. You know, they've got a little L on them. They've got threads at the top. Something else to keep in mind is this amount of room that's left from the top of the bolt to the top of the base plate. You need to make sure that'll often be specified in your drawings.
Okay.
Because that's some place that we got in trouble in San Antonio as well. Was, let's look at, so it's going to be on your base plate details. And we can see right here. So the distance we're talking about is the distance from here to here. Okay. They call it out to be 4 inches. Very important because they want to put a leveling nut underneath their base plate. Then you've got the base plate, then you've got a nut on top, and you've got to have some thread exposed at the nut. So in San Antonio, these were only, they ranged anywhere between 2.5 inches to 3 inches. Okay. That's a problem because what happens is even if you do away with this bottom nut and then you've got a base plate. So if you've got the top of the footing right here and you've got an anchor bolt that's through here, I'm going to draw this to exaggerate, and so say this is only 3 inches. Well, now all of a sudden your base plate is 2 inches thick. So your base plate's there and now your nut is here. So you're only able to get this many threads on that nut. Huge problem. So that it's not going to be secured. So even if everything had worked out in San Antonio, Sal was still going to end up tearing that stuff out because he didn't leave these J bolts were not up enough, right? And that's as much on our superintendent that was on the job at the time as it is the concrete guy, because that's something that is so easy to measure, right? They've got that they've got this in place. So like right here is a perfect example. All you got to do is measure from the top of that base plate to the top of that nut. That's it. You know, and take into account your base plate thickness, right? Because the concrete's going to be poured to the bottom of this base plate template. So add that and you should be at least at that 4 inches. Okay. So you end up with this right here, you know. This picture over here, again, you're not going to see this in Texas because what they've done is they've excavated for their grade beams. And they've actually looks like they poured their footings first. So then they're putting their grade beams, or maybe this is a foundation wall. I can't really tell. But either way, they've got it formed up. Instead of earth forming, they've actually used forms. So you'll see that in the Northeast all the time.
Okay.
All right. Any questions on anchor bolts or anything not make sense?
No, I think it really does. I think it really just goes back to the plans. And I think a lot of things can be preventable. As educated as the super and the PM are on the plans, you can avoid a lot of things, but then at the same time, sometimes things may just happen, like with the cylinders and that type of testing. But as far as quantities or measuring, like the situation you just said in San Antonio, things can be preventable. And
absolutely,
just getting ahead of that before it's a little bit too late.
Absolutely.
I think, but
it's the name of the game. Absolutely the name of the game. All right, let's run through some rework and some risks just to kind of give you a little bit of an idea on how much stuff costs. And these are going to be some wide variances, right? But because every situation is different. But like anchor bolt out of tolerance, absolutely, it's a 5 to 20 grade take. And more importantly, it's the time delay too, right? Because now you've got to go back and rework everything. Like, I mean, in San Antonio, we lost 3 weeks, basically, is what it ended up costing us.
Oh, wow.
In time. So the obvious preventable action there is going to be do your templates before, survey everything before you actually pour the concrete. Absolutely have it surveyed That way we have somebody else looking at it. Rebar cover is short, touching the form. That's again where if most common occurrence for that is going to be like like I talked about in like a parking lot where you see rust, and that's because some of the slab is exposed. Or excuse me, some of the rebar is exposed. It wasn't sitting down far enough. Failing a 28-day break. That doesn't really happen that often, honestly. It is a rarer situation. But it's very scary when it does because it could potentially cost you a lot of money. Concrete placed beyond slump spec. And again, that's going to be whether it was too hard, so your finish is going to be very difficult to achieve, or if it's too wet. And usually that's not a problem either after the fact, because that's why we do the slump before we even, the concrete company, and it's as much for the concrete company's benefit as anybody's, because if it's wrong, they're going to have to redo it at their own expense. So they will typically wait until that testing lab does his slump test and gives them the thumbs up, and says, all right, you're good to go. They will all typically always wait. So usually you don't have to worry about that after the fact.
Okay.
Cold joint. So that's if you've got we try not to have unplanned. So we should be able to plan all of our cold joints. That's part of like when we talked about the trench, and where we have cold joints. Maybe the concrete contractor comes to you and says, you know what, we don't want to do that. We're not going to pour it like that. And like, we're not going to dictate to them how it gets poured, because that's means and methods, right? So we can only give advice on how we think we should be poured. But maybe the concrete guy says, you know what, no, we're going to do that one, but then we're going to pour this all at the same time. So we're going to pour the wall and this portion, basically this is Z. We're going to pour this all at one time. Okay, fine. How are you going to do that? Explain to me how, and this is what the superintendent should ask, or this is what you can ask in a meeting. How are you going to do that? How are you going to make sure that this wall is poured correctly and that this slope is all correct and we're maintaining, because don't forget, we have some hold dimensions here. We absolutely have to hold and maintain. That 4'10", that 2'2". I mean, all of these are critical dimensions. So how are you going to do that? And then sometimes during that conversation, they explain it to you. Okay, no big deal. They're taking the risk for it. Other times, if they may actually change their mind and say, you know what, you may actually be right. We may just put a cold joint here because it's going to be very difficult for us to maintain these dimensions up here when we're trying to pour and maintain all of this. So.
And then if you were to have that, sorry,
go ahead.
if you were to have that conversation with the concrete contractor, would you then have it documented? Like you would say, you are going to be doing this, sign here if it doesn't go that way? Not
really a sign here. It's more of a sending them an email, or this is in your pre-install notes. So it's on your from the meeting that y'all have had for the pre-install meeting. It's not just a verbal conversation. It's documented in the notes. And then that's distributed out to everybody at the, after the meeting, so they know exactly what was discussed and what was talked about. And yeah, it's documented, right there. So, but no, you always document everything. So it's not, that's how we get in trouble with the verbal conversations. It's you always have to document everything, whether you're talking to a sub, whether you're talking to an owner, whether you're talking to an engineer that makes a site visit. Control joints cut too late or at the wrong depth. That can be a big problem. They will typically always specify, it's not always going to be a drawing that's going to show you the control joint. Sometimes it's just a note that says, okay, we need to do 1/2-inch control joints, every, within 24 hours. Let's look here real quick. Reinforce. So a lot of your notes, right? So for like concrete, here's your PSI, slab on grade, foundation wall, footings. It's not in the footing schedule. It's right here in the notes that tells you what your PSI should be. It also gives you your laps. So if you've got number 8 bars, it's got to be 4 foot. You have to lap those lap splices of 4 foot. That's a big lap. What are we looking for here? I forgot what I'm looking for. Oh, control joints, saw cuts. These are all the loads that they talked about. That's talking about the air. So this is all related to your mixed designs. I don't see any notes here. So what I'm going to do is go over here and search word saw cut, and I don't see any. So then let's do control. No notes there either that I can tell. That's assuming that the file is actually searchable. But anyway, so usually there's going to be, that's why it's very important to read all the notes, especially for a superintendent. Because like I said, that water stop note, it's nowhere else other than that one little note. It's not called out in the details. Would it be easier if it were called out in the details? Well, hell yeah, it'd be easier to call out in the details, but it's not. See, this tells you also, so the wash base slab on grade is 6 inches of concrete with the welded wire on a 10 mil vapor barrier. So if a contractor wants to deviate from this, so say they want to do rebar instead of welded wire, that's where we have to ask the question, just to make sure. Because they specifically say they want welded wire. So if somebody wants to use rebar, it's probably fine. We just need to ask the question. And they may want to use rebar. So like if they want to use rebar, it could be because they have it left over from a previous job. It could be that they have it from whatever. So there's usually a cost related reason. Here's our control joint. So our document is not searchable, unfortunately, because it should have pulled up control. But so construction control joints shall be a max of 15 foot on center. Joints shall follow walls where possible. Joints shall be installed within 24 hours of concrete placement. C, and it actually gives you a detail 4 on S2.0. So let's go to detail, or go to page 2.0. Let's go to detail 4, which is going to be right here. All right, so here they actually give you a expansion joint. And I know that that's an expansion joint because you can see it goes all the way through both pieces of concrete. So that's where you have two pieces of concrete coming together. You should always have a dowel going from one piece to the other. So you will see this most commonly in parking, concrete, paving, dowel to existing. So if you're doweling here we go. So they're tying in a piece of concrete here, and you see these dowels. That's to help reinforce that joint and to tie those two pieces together.
Okay.
So you will see that a lot. Like that's for like driveways, if we're doing, or we've got if we're doing a phasing schedule on our paving plan, and when we have two pieces of paving meet, this is what you'll have if we're doing concrete. Okay. You won't have this for asphalt because asphalt moves anyway. Asphalt's porous. But yes, so you'll have those will be dialed in just like that. Now, the control joint, this is where you're saw cutting. So you're just running it, you're just running that saw, and it says to keep it, obviously you want to keep it above your wire, right? Another critical thing, this is why you want your wire, at least as far enough down to where you're not hitting it with the saw whenever you're saw cut. And I believe it said every 15 foot, right? So then you would take this slab. Let's go to the one that's less convoluted. So then you would take this slab. So then every 15 feet. So you're going to have a saw cut. So let's say there's one there, there's one there, there's one there, just for round numbers. You're not going to have any this direction because you're not more than 15 feet in this direction. Does that make sense?
Mm-hmm.
like you would probably have one here going this direction. That way it splits this 15 foot. This is probably more than 15 foot. So if this were 20 foot, you just put a saw cut in the middle. But this should be saw cut. Okay, and that's all that's talking about. And then honeycombing. We talked about honeycombing. So patching, removal. You know, you can always patch a honeycomb, but it's not like something that's really bad is not gonna help. We see it most often. I would say we see it on light pole bases because they don't take the time to vibrate it correctly when they pour the light pole base.
Now that you say that, I've seen that during punch list.
Yes. And so we'll talk about them maybe having to do a skim coat. That's where they go and they'll take some cement and they'll basically wipe down the column with it, and or the base or whatever they're doing, edge of the slab. If it's exposed concrete and you got the edge of the slab, it just looks awful. We'll have them go in there and rub it. We'll do the same thing on like the trench. So the trench wall, if they don't, you know, sometimes that'll end up honeycombed a little bit. We make them go in there and rub it, make it smooth, you know, make sure there's no voids. Of course, Division 3, these are some given spec sections for CSI division codes. You should see these match in our submittal log. I think in the submittal videos, I've got like templates that we've already named a lot of these and already done this for you. It's just a matter of having to put them in Procore. Let's see, pull budget versus actually weekly, track and verify cubic yards poured. So this is if we're self-performing concrete. Like you're not gonna go through and calculate on our jobs unless we're self-performing the concrete. And if we are, something's really gone sideways. But if we are, that would be the only time you would actually like calculate the number of yards that are needed, all that kind of good stuff. The concrete subcontractor, the ready mix lab, the ready mix concrete supplier, the superintendent are going to take care of all that. They're going to schedule the testing lab, you know, all that. You just need to make sure that it's being done, right? So, common budget overruns, excess concrete ordered. We don't really have, so where we would get into trouble is, and not trouble, I'm just talking about like monetarily, is if we, if say we're in Texas and we are excavating for a footing and the superintendent tells them to excavate more than what they really need to excavate for that footing. Well, we're probably going to get a charge from the concrete guy because now he's going to have to use more concrete to fill up that footing. Does that make sense? A superintendent should never dictate however they're going to earth form the concrete. You know, if now he should obviously say something if there's a problem, or if he sees something that's not, you know, out of the ordinary, or see something that is out of the ordinary, but he should never dictate. Like the other place you get into trouble with this is like on a slab. So if we're doing a car wash slab, right, and the concrete contractor, when you bought the scope out, he's not responsible for the fine grade of the slab, then whoever goes in and grades the slab before the concrete gets poured, they may grade it to where you've got 8 inches instead of 6. Well, now he's got to have 2 inches of extra concrete across the entire slab. So it's going to take more material. He's going to charge you for material, and he's going to charge you for labor for pouring that extra 2 inches. So just something to kind of keep in mind. Let's see, formwork. Let's see, pump truck standing by. Pump truck's usually that's why we put it on the concrete contractor to schedule his own pump truck. We don't want to get into that communication with the concrete contractor. More importantly, because it could end up in a back charge from them. So rework for failed inspection, and then of course sub markup for scope gaps. Yeah, all that's pretty standard. All this is kind of standard stuff. It's not like, again, the rule of thumb, a subcontractor should not proceed with changes until they're approved. You live by that, and it eliminates a lot of surprises. So, Let's see. These are just some questions, some more questions that you can kind of go through and kind of look at. Just a little bit of, if you want to do a little bit of homework on it. Um, I don't really see any given a sample delivery ticket. Like you're not going to see delivery tickets unless you're on site
Hmm.
the day of the pour. It's so that's not a really big deal. The
But the
breaks.
delivery ticket, you would want your super to include that in their daily log.
Yeah, it really should be. Yeah,
Yeah.
if they so a lot of times what they'll do is when they deliver the concrete, the ready mix folks will will have one place where they go and they put all the tickets. So a concrete truck comes in, he's got a ticket, and he puts it, say, on the pump truck. That's actually where they stage a lot of them.
Okay.
So they'll have um, yeah. So because the pump truck stays there, right? So
Hmm.
they'll typically have a big magnet or they'll have a clipboard that's attached to this pump truck. And then when this concrete contractor comes in, or this is the ready mix supplier. So when this concrete supplier comes in, he dumps that concrete into the pump truck. He takes the ticket and puts it on the board. And then at the end of the job, at the end of the pour, the superintendent should have a stack of tickets,
Hmm.
you know.
Okay.
And then, yeah, he can absolutely include those, should actually absolutely include those in his daily report. Um, just to give, not to sidetrack too much, but because a concrete pump truck is we use them a lot because it makes it a lot easier, right, to pump the concrete.
Hmm.
But so it actually comes in, so you can see it's got all this stuff. So basically, what happens though, this is called a hopper, and the concrete truck will back up to this hopper. Sometimes you'll have two of them backed up and dumping concrete in. And then it goes through all of this again. Something that's the reason that we vibrate the concrete is because a lot of times by the time the concrete comes from here all the way through, it goes through this boom, excuse me, goes through this boom pipe out the tip. There's the ratio of cement to aggregate is different
Okay.
than when it started, when it came out of the truck.
Okay.
So
And
that's
I
another reason to be sure you vibrate it.
okay. I think I was there, maybe I'm making this up in my head, but I think I was at the Salina one of the days that Salina was pouring concrete, and was somebody on the pump truck, can somebody hold on to that and like move it around?
Yeah,
Okay, that's how they
yeah.
use it.
Oh yeah, absolutely.
Okay.
So let's go to see if we can actually find a guy in a hole here. Let's go. Yeah. So there you can see. So see this guy
Okay.
is moved. This is called the boom.
Hmm.
So then he is moving that around, and then you've got guys behind him that are going and spreading it.
Okay.
That's exactly how a pump truck works.
Okay. That was my understanding of it because I remember seeing it at one of the DFW car washes. Um, I don't remember which site, but okay, I've seen that before.
Yep. Yep. And one thing that they need to be sure that something that we've actually never had it happen before, is we were pouring in the Lipton car wash in Pittsfield, and the hose came disconnected right there and hit the guy in the head, and he fell over.
Oh
I had to
no.
take him to the hospital, ended up messing his leg up pretty good. Yeah, it was never seen it before, but
Yeah.
absolutely anything like that can happen. So,
And so with that situation, like, would you then start enforcing, or is it already enforced by OSHA to have hard hats on
oh
anytime you're
yeah, no, it's
inside?
enforced by, yeah, no, we should have hard hats on anytime you're on a job site.
Okay.
That's part of your PPE.
Okay.
Yep. Yep.
And
And they
he
did.
just had one on and it,
Yeah.
yeah. Okay.
Yeah, yeah. But that's something that, and like guys don't like to wear them a lot of
Yeah.
times because it's hot and they fall off and this, that, and the other thing. And but no, it's absolutely a requirement. And anytime that you need to have them all the time, but
Hmm.
especially if there's any work going on overhead, absolutely always wear one.
Hmm.
100%. And we like to wear one as well because that obviously one we set the standard, right?
Hmm.
If you've got if the PM comes on site and the PM's not wearing a hard hat, well then why the hell do I have to wear a hard hat?
Yeah.
You know,
Yeah.
stuff like that. So um, let's see, concrete breaks we've talked about. Yeah, I think all this is pretty standard stuff. Um, let's see here. Oh, okay, some more videos. I didn't even realize this was in here. I think I probably meant to delete this one, but actually, some of these are not going to be videos. Some of these are just some more, information regarding testing and OSHA drills. That's another. So the silica. Remember we talked about the dust from the silica.
Hmm.
That also happens like when you're core drilling or when you're drilling concrete, creates a lot of dust. And the silica is something. It's real. Like it's a real thing. There've been big lawsuits because of silica. Um, yeah. So like when you're grinding
Hmm.
or saw cutting or anything like that, like this guy, we need to have a mask on. It looks like he might have like a bandana on,
Hmm.
but he should have a mask on. And more importantly, like especially for something like this, and again, you'll learn this in your OSHA course, but we need that. Really should have like a respirator on.
Hmm.
That way it keeps them from, it filters out the air. And again, people don't like to wear them because they're uncomfortable. And you don't see the other thing with this is with silica, you don't see the effect like right then.
Hmm.
But after you do this, so after a concrete guy, if he's a saw cutter and he saw cuts all the time, so he does this for 5 years and he's breathing that in all the time, it's not good. He'll get sick. So anyway, um, let's go back to here. All right, cool. That's all I got. You got any questions or anything that
No,
didn't make?
no, I mean, not really. I think there were things that maybe I was confused about, but you answered it. Like, I don't think I ever really truly understood that the slab and let me make sure I'm saying all of it right. Um, that the slab and the foundation were two different things. I would have always just tied those in
Sure.
together. Um, the photos help. I just have been taking my notes and it's all making sense. Like the rebar, the vapor barrier, that I'm understanding and it makes sense as I'm learning it as to why that happens and why that needs to happen.
Okay.
And the videos that you sent beforehand, like the Burj Khalifa one. I have stood right in front of the Burj Khalifa and in the video when it shows it falling, I never would have thought anything about that.
Right.
But I never, when you're sitting in front of a building like that, you don't think about what's underneath it. And so I don't know, it's making sense and it's a lot of information. It is
Mhm.
just a lot of information to take in, but it makes more sense to me than civil does.
Okay. Okay.
Yeah.
Well, cool. Well, good. Well, and what I would recommend is like as we go through these, like as you get more involved into Dalton and especially when we start a job from scratch, you'll be able to go back to that particular section. So say we're about to do our first concrete pour next week for a job. You can always
Mhm.
go back and kind of review the concrete video, put it on 2X and roll through it until,
Mhm.
and just as a refresher, right? That's
Mhm.
kind of why we're doing this is so that it'll also give you a good foundation, but it's also a good refresher because some of this stuff like a lot of this stuff, especially like on the civil side, I haven't looked at a lot of that stuff in years,
Mhm.
sometimes. So, it's a good refresher for me too, to kind of go in and remember that, help put everything together, because it's
Mhm.
a lot of simple pieces, but all those simple pieces end up making a puzzle's not complicated, but if a 10,000 piece puzzle, it's a little
Yeah.
complicated. So, and if you miss, that's what we always say is if you have, if we're juggling 1,000 things on a job site, and if we just miss 1% of those, well, that's still 10 things that we missed that
Hmm.
could be critical, may not
Hmm.
be critical, come some. So just a lot to juggle. So,
Yes,
um,
I can see how it does help learning, like I can see where it's tying into the plans, on the civil plans and the structural plans, on the where things are called out. It
mhm.
is, it kind of like learning this has helped understanding where, um, I guess the knowledge I have with when it comes to reading plans, seeing
Okay.
where it's going to be like, um, I wouldn't have known that, you know, rebar number 4 is 1/2, or number 5, you wouldn't have known that reading the plans, but now learning it, it's like, okay, when I see that on the plans, that's going to make sense now.
Perfect.
Yeah.
Perfect. Good. Good, good, good. All right. Well, if you have any questions this week or whatever, about this, certainly, let me know. And it looks like we'll move into steel next week, which is going to be Division 3. So,
Okay.
or excuse me, Division 3, that's concrete. Steel is going to be, or metals is actually Division 5. So,
Okay.
all righty.
All right. Well,
All
thank
right.
you.
Hey, no problem. Have a great rest of your day.
Thank you, you too.
All right. Bye
All
bye.
right, bye.